So, for this episode, we're going to be covering inverse functions. Again, this is the second episode of our function series of our maths module. So, most times when people do these, they start with the do's. I'm going to start with the don'ts on this one. This is because when I was taught inverse functions for the first time, I was taught it very badly. So, I'm just going to quickly cover what went wrong, because maybe this has gone wrong for a few people. So, I was always taught that we were given something of y equals f of x. And again, this is what I was taught originally and what not to do. So it's just in case this is what you've seen, where it may equal, say, I don't know, 3x squared. So you'd be given the inverse function for that. We would know would be x over 3 root, really. And I was taught to give this as the function being f of y equals x over 3. I was also told to do it like f to the minus 1 of y equals root x over 3. That is definitely wrong. You've definitely done it this way. Technically this way does apply, because if I gave this a value of say 1, then you get 1 squared equals 3, and you take that to there, and then you can put that value into there and you'll get back your value of x, because that means y would then equal 3. You put 3 into here, you get 1 rooted, which equals 1. So that does actually work, but it's a bad way to do it. So this is not how you want to do this. This is not how you want to represent it. This is wrong. What you want to do is you want to ignore any values that anyone says equals to this or anything like that. Just take it as a function. Remember what I said, a function can be represented by anything. It could be, g of z if you wanted it to be, but we're going to stick with f of x because that's sort of the norm. And we're going to say that if we have f of x equals 3x squared, then we write the inverse as f to the minus 1, or sometimes people put f to the minus 1 there. It doesn't really matter where you put it too much, as long as you know what you're doing. And we will say this is equal to root x over 3. So that's how we write an inverse. But how do we get to that? So now this is where I do use y. So again, you can pick any variable, z, anything. We're just going to use y because everyone's used to using y. We will say now then that y equals 3x squared. And what we're going to do is we're now going to make our x the subject. So first we'll divide both sides by 3. So we get 1/3, that's not a very good 3, 1/3 y equals x squared. Then we're going to square root each side. So we can have, we'll write it in a different way this time, so you just get used to doing indices to the half equals x. So now our x is the subject, and this is our function. This is going to be our inverse function here. And what we do is we take a look at this and we go, right, so we are solving for x, really, and our variable is x. So our inverse function is going to be f to the minus 1 of x. And now we just take this side of the equation and put an x where the y is. So we can say equals, again I'll write it in this way, but remember this is similar to, well, it's the same as this, just with y and x there. 1/3 x to the half, which does equal root x over 3. So that's how we find an inverse. We'll show you another, and we'll discuss what an inverse really means. So another one we'll do, we'll take f of x equals, well, I don't know, we'll have 2 plus x minus 3, something very simple like that. You can just solve this, so you get this equals x minus 1, and then your inverse function, we just move the 1 to the other side, so we end up with x plus 1. Very, very easy one. You could have other variables in there which you don't know, which could be moved around. There's lots of different ways they can happen. You can have ones that you have to factor yourself. Yeah, so that's how you find an inverse anyway. So we'll say do one last one. So we'll do f of x equals 4 plus x squared. And what we'll do for this one then, we'll say this is equal to y again. We'll move the 4 onto the other side, so we get x squared equals y minus 4. We'll root both sides, so we get x equals root y minus 4. So then we call our inverse x to the minus 1 of x equals root x minus 4. And that's how you find an inverse. So I mean, you just take a function, you make it equal to a variable. So we've taken the term we have, made it equal to y. We have then just done step by step, and we've solved for x. And then you always write it out as a function of minus 1 equal of x variable equals the term that's subbing x back in. So we're going to take a very quick look at a few of the things, like this is the minus 1. This means this is an inverse function. This is not to be confused with if you have something like x to the minus 1, which equals 1 over x. Okay? That is not the same. F to the minus 1 of x does not equal f to the minus 1 like that, because that equals 1 over f of x. You see? That's the difference there. And finally, I'm just going to quickly talk about something which you want to notice when you look at functions, which is if we have a function f of x, and we're going to make this function equal to 3x plus 2. So our inverse function then, if we we'll just quickly do our inverse. I'll do it step by step so we can see. And we have this is equal to y. So we move the 2 across, so we have 3x equals y minus 2, and x equals 1/3 y minus 2. Okay, so that's our inverse function. So our f to the minus 1 of x equals 1/3 x minus 2. Just quickly write this across at the top. So we have our f of x equals 3x plus 2, and f to the minus 1 of x equals 1/3 x minus 2. Now what you can do is you can plug either way around. If you put in any value of x, so if you say x equals 2, and you put in f of f minus 1 of x, this also equals f to the minus 1 of f of x, and both of these equal x. Always do. So I'll show you this works. So what we're going to do is we're going to plug in f of a minus 1, we'll do this one, into f of x. So that means we have 3 1/3 x minus 2 plus 2. So we can now multiply the 3 by a third, which equals 1, so they get rid of each other. So now we're left with x minus 2 plus 2. Then they cancel, so we're just left with x. It always equals x. That's how an inverse function can work. Right, thank you very much. And we're next going to move on to odd and even functions.